You're already doing physics. When you catch a falling phone, lean forward as a bus suddenly stops, or wonder why the moon doesn't fall out of the sky, you're reacting to the same rules physicists study. The difference is that physics doesn't stop at saying, "that happened." It asks, why did it happen? And can we predict what happens next? Before we start solving equations, there are 4 things you should understand about physics. First, why should you learn it? Maybe you're studying physics because it's required in school. Fair enough. But physics is much bigger than passing an exam. Your phone, headphones, GPS, electricity, medical scanners, airplanes, computers, even the screen you're watching right now exist because people learned how nature behaves and used that knowledge to build something. But the best reason to learn physics isn't just technology. Physics trains you to look at a complicated situation, remove what doesn't matter, and find the few important rules hiding underneath. That way of thinking is useful far beyond a laboratory. So, what exactly is physics? Physics is the study of the basic structures and interactions of the physical universe. That sounds massive, because it is. Physics can examine something smaller than an atom, something as ordinary as a moving bicycle, or something as large as a galaxy. But physicists don't try to study the entire universe at once. They choose one part of it to focus on. This is called a system. If we're studying a falling ball, the ball and Earth might be our system. If we're studying a room becoming warmer, the air, walls, and heater might become the system. Then we identify what can be observed or measured. Things such as time, length, mass, speed, energy, and temperature are called physical quantities. A quantity needs a number and a unit. Saying someone's height is 1.75 is incomplete. Is that meters, feet, or something else? The unit gives the number meaning. We'll explore quantities and units properly in the next video. For now, remember this. Physics turns observations into measurements, and measurements into relationships. But how is physics actually done? It usually begins with something strange, interesting, or unexplained. You observe it, you ask a question, you suggest a possible explanation, a hypothesis. Then you test it using evidence, measurement, or an experiment. If the result disagrees with your idea, you don't force the evidence to fit. You improve the explanation and test again. However, science is not always a perfect 4-step recipe. Discoveries can also begin with accidents, unexpected results, new technology, or even thought experiments. The important part is that scientific explanations must face evidence. And one quick correction, a theory does not simply graduate into a law. Scientific laws describe consistent relationships, while theories explain how or why phenomena occur. Both can be strongly supported, but they serve different purposes. Finally, how do you learn physics? Not by memorizing every definition and equation. An equation is not a magical collection of letters. It describes a relationship between quantities. To understand it, you must ask, what does each quantity represent? What happens when one changes? Do the units make sense? Can I connect this equation to something real? Learn the vocabulary. Visualize the situation. Draw it. Estimate what you expect. Solve it. And then check whether your answer is reasonable. Physics is learned by doing. So, as we begin this playlist, don't worry if you don't immediately know the answer. Start by asking better questions, because physics isn't really about memorizing the universe. It's about learning how to read it. And the first thing we need to read it is measurement.